You've heard of solids, liquids, and gases. In a solid, the particles are mostly fixed in position, but they do wiggle and jiggle a little bit. They still have kinetic energy, which means they still have a temperature, but they don't have the freedom to move like they do in a liquid and a gas. There are intermolecular forces, or the forces of attraction between nearby particles within a solid, and they're relatively strong. That's kind of what keeps them in that fixed position. If you add energy, it'll turn into a liquid. The particles are a little bit more random, they have more freedom to move around, and they have a higher average kinetic energy. There are still intermolecular forces that keep it in a relatively condensed state, but they're not as strong. For a gas, the particles have a lot more freedom to move and a lot more energy, so they bounce off of each other a little bit, but more so they bounce off the containers, and they have just so much energy that they're moving in a certain direction, we have to contain them in containers like balloons and cylinders and stuff. Now let's talk about the terms you'll hear that are associated with the phase changes. When a solid turns into a liquid, in everyday life we call that melting, but in science speak, that's fusion. When a liquid turns into a gas, we call that vaporization. And that's because a gas is a vapor. Now, a solid can turn straight into a gas by skipping over the liquid phase, and that's called sublimation. Now let's go in the opposite direction where we're taking energy away. So when a gas turns into a liquid, we call that condensation. That happens in clouds as water vapor cools and condenses into liquid water droplets that can eventually fall as like precipitation. Also happens on like car windows and grass, which is dew and all that kind of stuff. If you take away even more energy, then the liquid will turn into a solid, and that has an interesting term called solidification. And just like it's possible for a solid to turn straight into a gas by skipping over liquid, it is possible for a gas to turn straight into a solid by skipping over liquid. And that's called deposition. So what do these have to do with energy? As we go from left to right, we're adding more energy, and that term is endothermic. Endo means into, and thermic refers to heat energy. So you got to add heat energy to go from a solid to a liquid, and then a liquid to a gas. The opposite of endothermic, where we have to take energy out, that's called exothermic. Exothermic, we have to cool it down. So gases have higher energy than liquids. Take even more energy out and you turn into a solid. Exo means out of, and thermic refers to heat energy. So we're taking heat energy out of the system, cooling it down. For water, the transition from solid to liquid occurs at the melting point, which is 0 degrees Celsius or 273 Kelvin. And the transition from liquid to gas, where all the particles have the energy to turn into a gas, that occurs at the boiling point, which is 100 degrees Celsius or 373 Kelvin. As a quick aside, you might notice that there is a difference between Celsius and Kelvin. To go from Celsius to Kelvin, you simply add 273. Technically, there's like a 0.15 and some change, but you don't really need to worry about that too much. And to go in the opposite direction, you subtract 273. So that's how you change from Celsius to Kelvin. The reason that Kelvin is a useful scale is, remember how I said that in a solid, they're locked into place, but they still have some movement, they still wiggle and jiggle a little bit? That means they still have some kinetic energy. Theoretically, if you could take all of the energy out of a solid and make it as cold as possible, the minimum temperature, which we call absolute zero, that's 0 Kelvin. That's when even the particles themselves are no longer wiggling and jiggling into place. 0 Kelvin is the lowest possible temperature, and it's a theoretical limit, which means if you could take every little itty bit of kinetic energy out of even the smallest movements of the atoms and molecules themselves, that would get you to 0 Kelvin. But that's not an actual possible temperature. We've just gotten really close. So as a review, fusion, solid to liquid; vaporization, liquid to gas; sublimation, solid straight to gas. In the opposite direction, where we're cooling it off, condensation, gas to liquid; solidification, liquid to solid; and then deposition, gas to solid.